factor the polynomial 6x squared y squared minus 2x squared, or xy squared minus 60y squared. So I'm thinking there's going to be a common factor for all three terms. Let's look at the number factors. 2 is the smallest number, and all of the other numbers definitely have a factor of 2. Now, x is not in the last term, but y is in all of the terms, and the lowest exponent is 2. They're all the same. So 2y squared is going to be our greatest common factor. Let's divide from each of the terms to see what our remaining trinomial is. For the first term, 6 divided by 2 is 3x squared, and the y cancels out multiplicatively. In the middle term, both 2 and y squared cancel out, leaving just minus x. In the last term, 60 divided by 2, that's a minus 30, and the y cancels out. So now we want to see if the remaining trinomial can be factored. So factors of the first and the last term such that the sum of the products of those factors is the middle term. Starting with x squared, because that's easy, x times x. And 3 is a prime number, so it can only have a factor of 3 times 1. 30, however, could be 30 times 1, 15 times 2, 10 times 3. Or 6 times 5. So let's see. 30 times 1, probably not going to work. We need to add up to a 1, so I'm thinking it might be like 5 times 6. Let's see. So if we multiply across, that's 15x and 6x. That's not going to work. If we switch the numbers, so if we put the 6 up here and the 5 down here, then we'll have 18 and 5. That's not going to work. So 6 and 5 are not going to cut it. Let's try 10 and 3. So that'll give us 30 and 3x. That's not going to work. How about the other way, 3 and 10? So that'll be 9x and 10x. That might work. Let's look at the signs. So if the product is negative, we have different signs, and the bigger number is going to be negative because the sum is negative. So a negative 10 and a positive 9. That works. So let me put those signs in and take those cross terms for my factor of x plus 3 and 3x minus 10. Just don't forget your GCF out front to complete your factored form. Our next example, we have 8n squared minus 40n plus 50. So looks like all of those numbers are even. I could definitely take out a factor of 2, and that might be it. So let's see what happens when we factor out a 2. Then the first term, 8 divided by 2 is 4. The middle term, 40 divided by 2 is 20. And the last term, 50 divided by 2 is 25. So now we want to see if we can factor this trinomial. So factors of 4n squared and positive 25 such that the sum of the products of those factors is the middle term. So n squared's got to be n times n, but 4 could be 4 times 1 or 2 times 2. 5 could be 25 times 1 or 5 times 5. And I like to try the smaller numbers first to see if those work out. So let's try these to start with. Multiply across, that's 10n and 10n. We've got the same sign for a positive product, and that means they're both negative. And that does add up to what we want. So if we go across, we have a factor of 2n minus 5. And another factor of 2n minus 5. Just don't forget your GCF out front to complete your factor. So now we want to factor this polynomial here, and I definitely know I have a special GCF of a negative. If your first term is negative, you must factor out a GCF of a negative. So let's see if there's any other factors these might have in common. 21, they all divide by 3. So there is a common factor of 3. And that might be it. So let's factor that out and see what remains of this trinomial. For the first term, that's going to divide to a positive 2x squared. In the middle term, that goes in 41 times. And last, that's going to be a negative 7. So let's see if we can factor the remaining trinomial here. Factors of 2x squared and negative 7. And our adding goal is a positive 41x. Factors of x squared are x times x, and 2 is a prime number. And 7 is also a prime number, so we can either do 7 times 1 or 1 times 7 here. Let's multiply across 14x and 1x. That's not going to add up to 41, so let's try it the other way. 1 times 7. There's no way that's going to add up. Those are the only factors because these are prime numbers. So that means that the trinomial is not factorable, but we do have these factors.